Welcome back, everybody. Today we're going to be talking about 7.2 similar polygons. In the past, we've talked about congruent triangles, congruent polygons, but this time they're going to be similar. Okay, so we're going to discuss what it means to be similar. So we're going to be identifying two similar polygons. I'm going to give you two shapes, and what you're going to do is you're going to determine whether they are going to be similar or not, and you're going to use the lesson what you learned yesterday, the ratios and proportions, to see if their sides are going to be proportionate with equal ratios. And we'll get into that in just a little bit. But first, I want you to write this down. Please write this down. Write down what a similar polygon is. Similar polygon. So give this one a shot, I guess. Don't really have to do anything. Just write this one down, please. Pause. All right, so now when we look at this polygon, okay, two polygons are similar polygons if and only if. That's very, very, very important. It is only possible if their corresponding angles are congruent. Okay, corresponding angles are congruent. But you also need corresponding sides are proportional. So the very first thing is you need to know that all of their angles are the same. Secondly, you need to know that all of their sides are going to be at the exact same ratio. So if you look at this shape, okay, if you look at down in the statement section right here that I just circled, if you put AB over EF, so in this statement we put small over big. Okay, you will notice that the top one is always going to be your small section. Your bottom one is always going to be your big section, and they kept that ratio the exact same of small over big, small over big, small over big, so on and so forth. Okay, and the ratio is going to be the exact same of 1 over 2. When you have all of these angles that are congruent and you have the ratio that is the same, they are going to be similar. And it is written in a similarity statement, okay, this right down here that I underlined, that's going to be known as a similarity statement. It's a statement that shows similarity. Okay? And this symbol that you see in between them, that's known as the similar symbol. So if you look at a congruent symbol, here's a congruent symbol. Notice that all the similarity is we took out the equal sign, and it's just a little squiggly line. Okay, that's known as a similarity sign or a similar sign, and the ABCD is similar to EFGH is your similarity statement. Okay, so let's try a problem. So here's the very first one. I'm going to give you a similarity statement that I want you to write down. I am going to say that triangle ABC is similar to triangle JGH. That is a G. Okay? So what I'm going to do is I'm going to walk you through what this looks like when we identify the congruent angles and the corresponding sides. All right, so congruent angles. You look for angles that have the exact same measure. All right? And you can identify those in the similarity statement as well. So if I look at this, A and J, okay, are in the exact same position. Now if I look at my drawings and I notice that A and J, they are going to be similar, or they're going to be congruent to each other. And I know this because the other angles of 59 here and 90 degrees here are going to be congruent to each other. So that means by the angle addition postulate, they have to be the exact same. Okay? So when I look at this, make A is going to be congruent to angle J. Then I just match up everything else. Angle B is going to be congruent to angle G because they are both 90-degree angles. And angle C is going to be congruent to angle H, because they're both 59 degrees. Okay, so we know that congruent angles part of it. Now what we have to do is we have to identify the corresponding sides. And that's going to be just like we used in our congruent statements. We're going to use the exact same idea in our similarity statements with our corresponding sides. And it looks similar to this. I know that AB, okay, that's the large angle, and I'm going to keep the ratio of large over big. And if I had to look at the smaller triangle, or at my similarity statement, I know that JG represents the corresponding side of that smaller triangle. They're not equal to each other, it's just the ratio of AB over JG is going to be equal. So that ratio is going to be equal to BC. Notice BC is 6, and the next one would be GH. They are the exact same. That ratio is the same. And AC is going to have the exact same ratio as JH. And the reason behind that, how I know that, without even, if that didn't even, those triangles weren't even drawn, okay, I am given that information in this statement right here, that similarity statement. What I am saying is not that AB is going to be congruent to JG. I am saying that the ratio of AB over JG is going to be the exact same ratio as BC over GH, and that AC over JH is equal to the other two as well. Okay, so the ratios between all of those are going to be the exact same. Right? So for instance, if I look at AB over JG, AB over JG is the same thing as saying 10 over what? What corresponds with JG? That's going to be 5, which is the same thing as 2 over 1. Same thing with BC. BC over GH, it's going to be the same as 6 over 3, which is 2 over 1. You will notice that their ratio is exactly the same. The last one of 11.6 over 5.8 is also 2 over 1. Okay, so all of their ratios are the exact same, which makes them similar. But we don't really need that picture. I just wanted to show you that. We need this statement right here. That's known as a similarity statement. This is how we identify the congruent angles. This is how we identify the corresponding sides, just like that. All right? Sweet. All right, so looking at this problem, it states, determine whether the polygons are similar. And it says, if so, write the similarity ratio in the similarity statement. So when we look at this, the only way to figure out if the polygons are similar is, first off, are all the angles the exact same? Are they all congruent from one polygon to the next? Okay, and then the second one is going to be the similarity ratio, the ratio between the two objects. Okay, so when you look at this, I'm going to set this one up. Very first thing is, do we have a congruent shapes? And the shapes are not going to be congruent here, but our angles are. So all of our corresponding angles are going to be congruent to each other because these are two rectangles, all 90 degrees. Okay, so now we have to have a similarity ratio. And when we set up a similarity ratio, you have to set up, get two segments. So I'm going to start here, and I know the measure of side BC. Okay, so if I look at this side BC, I'm going to put it over the side that is going to be the corresponding side on the other one, which will be FG. Notice I have the long end here of one of this first rectangle, and I have the long end of my second rectangle. So I look at this, and my proportion basically, my ratio looks like, so the long segment on the big rectangle, and then I have the long segment on the small rectangle, and I put it over one another. So my segments, or that ratio, is going to be 9 over 6. And when we simplify this, simplify 9 over 6, what do you get? 3 over 2. So my ratio between the big segment, or sorry, the big rectangle to the small rectangle on BC over FG is 3 over 2. And what we have to do now is we have to see if that matches up with the other segment or the other information that we know. Okay, so set it up. We now have BA over FE. And the reason why we have BA over FE is because now we have the short of the big over the short segment of the small. Okay, notice I always put the big over the small. You can put big rectangle over the small rectangle, or you could put small rectangle over the big rectangle. It doesn't matter as long as you do it for each and every ratio. Notice on this first one, I put the big rectangle on top. Second one, I put the big rectangle on top, and I needed to keep that same ratio. Okay, so now I have 6 over 4. Simplest form, I use that, and that's going to divide by 2 each one, and that's also going to be 3 over 2. So what is my similarity ratio? I just wrote it. That's going to be 3 over 2, and that work states the similarity ratio. So I'm just going to do BA over FG is equal to BC over FG, not BA. Okay, and then BA over FE is the second one, and that's going to be equal to 3 over 2. That's my similarity ratio. It tells me that these two are going to be equal to each other, and that 3 is over 2, which is my ratio there. Next one is my similarity statement, and this is going to be that statement which proves the rectangles are similar. So this would look like ABCD is going to be similar to EFGH. So that is my similarity statement right here, and I have my similarity ratio right here. Awesome. Okay, so let's try another one. So this next one, I'm just going to go through the directions. It says, determine whether the polygons are similar. If they are similar, write a similarity statement and find the scale factor. And what this scale factor is, that's just another name for your similarity ratio. So that's going to be, like we did on the rectangle one, it's going to be that similarity ratio of that. The last problem would be 3 over 2. So now you're finding the scale factor or the ratio of these corresponding sides. Okay, so I want you to give this one a shot all by yourself, see how you do, and we'll check it out afterwards. Good luck. All right, so now on this one, the very first thing is, do we have similar triangles? And the answer is yes. Okay, because if I look at this, angle M is going to be congruent to angle N. We know that because they're both 90 degrees. Angle L is going to be congruent to angle P. Why? Because they have that angle marks. The last one is going to be angle J is congruent to angle S, and that's because we have the interior angles theorem of a triangle. Okay, if we know the two, we know what that third one is, and they have to be equal to each other. So J is going to be congruent to S. So are these similar? We aren't sure yet, and the reason behind that is because we need to figure out that their ratios or their scale factors are exactly the same. Okay, so now what we have to do is we have to set it up. So when I look at this, I am always, on this one, I'm inclined to always put the big triangle, so the big triangle over the small triangle. So I'm going to do that for each and every ratio. I'm going to put the big over the small corresponding segment. So if I look at LJ, I'm going to put that, notice that is my hypotenuse on this side. So I'm going to put that over the hypotenuse on the smaller triangle, which is PS. Okay, so LJ over PS, I'm going to set them, and that's 75 over 30. And when I look at this, I can divide each one by 15, and I get 5 over 2. When I simplify it down. Next one, I am going to put LJ, not LJ, LM, this side, and that's going to be the corresponding side of PN. So LM, I keep saying LJ, over PN. And that triangle looks like, or that side is 60 over 24. And when we break this down, we can divide each one by 12, and it's 5 over 2. So are they similar so far? Absolutely. But now we have to figure out if that last segment makes them similar. Okay, so now we look at this, and we are looking for MJ Michael Jordan, okay, over NS. And we're going to set that equal to 45 over 18. And when you divide this, you can divide each one by 9, and it's going to be 5 over 2 again. So are these two triangles similar? Yes. Why? Because we have congruent angles, and we have the corresponding sides are the exact same ratio. So if you look at this, in our similarity statement, we are going to make a statement like this that looks like MLJ, triangle MLJ, is going to be similar to triangle NPS. Okay, MLJ is similar to NPS. Notice I have my corresponding sides and my corresponding angles all set up in the correct place. All right, and it asks for the scale factor, which you already have given, which is 5 over 2. If it is not, if all three of those were not 5 over 2, then it's not going to be congruent, or not going to be similar. Awesome. Next. Okay, in this problem, what I want you to do is I want you to find the length of the model to the nearest inch. So now we know that they are going to be similar. Now the way we're going to figure that out is we have to set up a proportion. So what I want you to do is set up a proportion. See if you can set up a proportion and find what x is. So set this up now. Okay, so when I look at this, again, I like to set this up into the correct ratio or the correct proportion. What I do on one side, I have to do to the other. For instance, if I'm going to put long, my long side of the big triangle over the short side of the big triangle, and I'm going to set that equal to the long side of my small triangle over the short side of my small triangle as well. So notice on both of these ratios, this is a proportion because I put long over short on one side and I put long over short on the other. Okay, so because of that, I know that's going to be the correct setup. Okay, you could have also put short over long on both sides of the proportion. You could have also put long over big over long over small, and short over big over short over small. That's giving you big over small over big over small. Sounds very confusing. But when you set this up, you come up with an answer, and let's see if your answer is correct. So this is going to be 36.25 over 9, and that's going to be equal to x over 1.25. So from here, we're going to cross multiply. Going across, you get 36.25 times 1.25 is equal to 9x. When you look at 36.25 times 1.25, you're going to get 45.3125 equals 9x. You're going to divide by 9 on each side, and x is going to be about to the nearest inch. It's 5.034722222, but you're going to get x nearest inch is going to be 5 inches. Okay, so that is the proportion. Again, you have to set up the proportion correctly to get the correct answer. Again, on both sides, I put the long over the short. Same thing, so long over big over short over big, and then on the other side, long over small over short over small. So keep those that ratio correct. All right, next one. Okay, this one is a theorem. It says if two polygons are similar, then the ratio of the perimeters is equal to the ratio of their corresponding lengths. So if you look at the overall perimeters of two shapes, if they are similar, their ratio will be the exact same. Okay, so that's the theorem. So we're going to try one more, last one of the day. Okay, so now it says first of all, find the value of x. Then you're going to find the ratio of the perimeters. Okay, we automatically know right off the top, it gives us our similarity statement of triangle PQR is similar to triangle STU. So from there, I want you to see if you can come up with the correct proportion to solve for the value of x first, and then we'll come up with the ratio of the perimeter. All right, so pause now, give that, see if you can find x. All right, so when you look at this, there's multiple ways you can do it. When I look at this, I'm going to take two sides and I'm going to set it up as a proportion. I'm going to find PR, okay, because we need to use PR because that's my x. I'm going to take PR over QR. So this side, that right side, over my base, over QR, and I'm going to set that equal to, again, the right side, which is SU, and same thing up here, I have PR over over QR is equal to SU over TU. Okay, so when you look at this proportion and you look at the similarity statement, okay, I took the segment of PR. That's going to be the top. So I need my first point and third point in the STU statement right here. So SU is going to be first. Then I took QR on bottom, which means the segment's second and third points here over to U. From here, I plug in what I know. X over 16 is equal to 9 over 8. Cross multiply, I get 8x is equal to 144. Divide by 8. And my answer is going to be 18. Okay, so now when I look at this, I know x is equal to 18. I'm just going to erase this because I came up with what x is. So x is equal to 18. X is 18. So now I have 14, 16, 18, and 7, 8, and 9. So now my ratio of the perimeter is going to be the exact same as the other one. So I know what is the perimeter of this first one? Well, if I look at the perimeter over PQR, so I'm just going to say PQR over STU. They are similar. We already know that. So what's the ratio of PQR? That's 14 plus 16 plus 18, which is 48, over STU, which is 7 plus 8 plus 9, which is 24. When you set this equal, you get the ratio of 2 over 1. Do you need to keep it as 2 over 1, or can you just write 2? Keep it as 2 over 1 because that's a ratio. You need a numerator and a denominator. So the ratio is 2 over 1. And my x is equal to 18. All right, so when we look at this, and if you went back and you looked at the corresponding sides, you will also know that it's going to be 2 over 1 when looking at PQR to STU. All right, so that is similar polygons. If you have any questions, please let me know. This lesson might get a little confusing, and if it did, I apologize. Let me know that it is confusing so I can explain it to you today. Okay, have a great day. I will see you later.